Geometry class consists of 23 juniors and 44 sophomores. A committee of 5 students is chosen at random. What is the probability that no juniors are chosen? So here, this is a probability problem involving combinations. Okay. So let's see how we're gonna use that. So here, obviously, we're gonna choose the probability will be estimated by the number of desired outcomes, okay, divided by the number of possible outcomes. Possible means everything possible, right? All outcomes combined. Okay? So here, let's break it down theoretically. So if we have n juniors and we have m sophomores, we want to choose and how many students in total will we have? We'll have n plus m students. Okay, so and we want to choose R. Choose R students. Okay, so if we want to choose R students, basically the number of desired outcomes divided by the number of possible will be, in this case, we want no juniors, right? So we want only the sophomores. So we're going to choose from the number of sophomores, we're going to choose R, okay? And we're going to multiply it by choosing 0 juniors from n students, right? Because there are n juniors, but we want no juniors, as it says in the problem. So we have to choose 0 students from the group of n juniors, okay? And divided by the number of possible outcomes. The number of possible outcomes will be m plus n, right? The total number of students. Choosing from that number, choosing R, right? Because there are R students to be chosen from everyone together included, okay? So now if you translate this combination fraction that we found into the numbers provided, first of all, what is n plus m? N plus m is going to be equal to 23 plus 44. That's equal to 67, right? That's the total number of students. Now R is equal to 5 because you want to choose 5 students. Okay. N is equal to 23 and M is equal to 44. Okay, so simply it's going to be 44, choose 5, times 23, choose 0, and dividing it over by 67, choose 5. Now, what does this mean? This simply means 44, 44 combination 5, because that's NCR, right? MCR in this case, times 23C0 divided by 67C5. Now, as you know, 23C0 is equal to 1. Okay? 23 choose 0 is 1. So if you have a 0 on the bottom, the top number will not matter. It will always be 1. Okay? So we're left with pretty much 44C5 divided by 67C5. And as you know, that's answer choice B. Now, if you wanted to avoid this method, you could have simply understood that you can choose 44 sophomores for the first spot times 43 sophomores for the second spot times 42 sophomores for the third spot times 41 sophomores for the fourth spot, and for the last spot you would have 40 sophomores, and dividing it over by choosing 67 students for the first spot, right? Because it's everyone together, the number of possible outcomes. That's why we start from 67 times 66 times 65 times 64 times 63. And that the equivalent of that using factorials would be 44 dividing it by 39 by 39 by 39 and also by 5, right? So what does this mean basically? This is the number of favorable, right, outcomes, the desired outcomes. When you choose your 5 sophomores, you want to make sure that these 5 sophomores are not ordered. So you don't care about the ordering, so you don't need permutation. You only need the combination. That's the reason why you divide by the 5. But also you have to divide by the 39, right? Because there are 39 factorial ways of permuting the kids that you did not choose, the remaining sophomores that you did not choose for your 5 places, right? And that's the reason why you divide by 39. So you have to do 2 things here. Now also for the number of possible outcomes, you have to do the same thing. So you're going to start from 67 factorial, and then you're going to divide it over by 5, of course, because you don't want to order the 5 kids you chose, multiplied by 67 minus 5, which is 62 factorial. Okay, so as a result, this becomes, this is translated to 44 combination 5, right? Well, I should say 44 choose 5. Let me just use more space to write it over. 44 choose 5, okay, divided by 67 choose 5. That's basically for you to understand the notation, the combination notation here, how it's equivalent, how to find the equivalent factorial form. Okay, so if you were to do it in this case, you would just have to, if you use this method of numbers, you would have to convert it to factorial and then convert it to the NCR form, and that's how you would find the answer choice B in this case. But you have to understand how the combination notation relates to the factorial notation, and this is exactly how it relates. Thank you so much for watching. Please subscribe, and I'll see you in my next video.